Okay, part 3 of our attributes of exponential functions. So we already went over parent function, the attributes, the exponential growth and decay, and the model. So the model is what we're going to focus on for this video, because we're going to go over the example of modeling exponential growth, right? So just make sure that we know what our model looks like and what each letter represents, right? So our example, which is on our Word document notes, states you have invested $1,000 in a savings account at the end of 6th grade. The account pays 5% annual interest. How much money will be in the account after 6 years? So we need to know what our exponential model looks like, right? Which is this right here. Now we need to know what each letter of our exponential model is. Everything that you need for this exponential model is given to you in this word problem. Okay, so that we need to dissect the problem in order to know what A, what R, and what T is. Of course, at the end, we're going to get what A is as well. So A, little a, lowercase a, means the initial amount, right? By the way, sorry if you hear weird noises. That is my bulldog, again, who I cannot get to settle down. Anyway, the lowercase a means the initial amount, right? So our initial amount is going to be $1,000. Why? Because that is what you start with, that you have invested $1,000 into a savings account. So that is your initial amount. Okay, so we put that to the side, right? Now let's find what R is. So again, in our exponential model, R represents the rate of growth or the rate of decay. So in this case, it tells us that the account pays 5% annual interest. So that 5%, that's going to let us know what our rate of growth is, or rate of decay is. But because it's telling us that it pays 5%, so it's giving 5%, then that 5% of annual interest is added to your account each year. So then that tells us that it's going to be a growth, because they are summing that annual interest to your initial amount, right? So you're going to take that 5%, but you are going to take your decimal place and you're going to move it over to decimal places, right? So we have our decimal place right here, and you're going to move it once, twice. So your real rate of growth is going to be 0.05. That is your R, because that is the growth. Yeah, so you can make a little note. So that's the rate of growth. Now T. On our exponential model, T represents the number of time periods, right? So they're telling us on our word problem, they're asking rather, how much money will be in the account after 6 years. So we know that the time is going to be 6, because that's the amount of time, 6 years. Right, so now we can go ahead and take all that, substitute it onto our model, and find what our total amount will be, right? So taking all that information, we're going to substitute it up here. So A of T equals, so our lowercase a is 1,000. Then we have 1 plus 0.05 to the power of 6. That is going to be simplified to 1,000 times 1.05 to the power of 6. And then if you, plug this into your calculator, that would be 1.05 to the power of 6 times 1,000. That is going to equal 1,340.10. So that is your total amount, right? So your total amount is $1,340.10. So now the question is, how much money will be in the account after 6 years? Well, this is how much is going to be on the account after 6 years. So all you're going to say is, okay, the account contains, $1,340 with 10 cents after 6 years. And that's it.